Here's problem 3047. A long solenoid, N equal to 80 turns per centimeter, carries a current of 70 milliamps. If the interior of the solenoid is filled with a ferromagnetic material having a permeability Km of 650, determine the magnitude of the magnetic field before and after the ferromagnetic material is inserted. If you have a regular solenoid like this, the magnetic field through the center of that solenoid, which we call Bs, is equal to mu naught times the number of turns per meter times the current going through that solenoid. In this particular case, we have to be careful. We're given the number of turns in terms of 80 turns per centimeter. That's going to be 0.01 meters, so that is going to be actually 8,000 turns per meter. So now we can calculate the magnetic field before, this is all before, we add the ferromagnetic material, and that's going to be equal to 4 pi times 10 to the minus 7 for mu naught times the number of turns per meter, 8,000, times the current, which is 70 milliamps, 70 times 10 to the minus 3 amps. And this is equal to 7.04 times 10 to the minus 4 Tesla. 10 to the minus 4 Tesla is a Gauss, so we would say that this is 7.04 Gauss. In other words, there's 10,000 Gauss in a Tesla. Alright, now if we add the ferromagnetic material, our solenoid will now be inundated with this material, and that's going to increase the magnetic field. In fact, the magnetic field now is going to equal that permeability times the initial magnetic field. The way we can look at it is this magnetic field is going to equal mu little n times the current through the solenoid, where mu is equal to K times mu naught. So this is going to be equal to K times mu naught little n current through the solenoid, which we can write as K times our original magnetic field, which will be 650 times the 7.04 times 10 to the minus 4 Tesla, and that's equal to 0.457 Tesla. So, by adding the ferromagnetic material, we increase the magnetic permeability of the substance inside. It's no longer air, it is magnetic material, and hence we end up with a much stronger magnet and much stronger magnetic field of 0.457 Tesla.